Hello, today I'll be going over 6.3, which is perform operations and composition. So here I have the table. I already set up some of the definitions. So for addition, that means we're adding two functions together. So they'll tell you what f of x equals and what g of x equals. So for addition, we have in the example column f of x equals 5x and g of x equals x plus 2. So that means h of x would equal f of x, which is 5x, plus g of x, which is x plus 2. And then we would just combine like terms. So this would equal 6x plus 2. Okay, next we have subtraction. So that's where we're subtracting them. So h of x would equal 5x minus x plus 2. So we're going to distribute the negative, and we would get 4x minus 2. Next, for multiplication, we're multiplying them. So h of x would equal 5x times x plus 2. So again, we're going to distribute. That'll give us 5x squared plus 10x. And then the last one, we have h of x equals f of x over g of x. So that'll just be 5x over x plus 2. And we can't simplify, so that would be our final answer. Okay, some more vocab. A power function is y equals a times x to the b power. Composition is when we have h of x equals g of f of x. So that just means you're going to plug in f of x into all the x's and g's. Hopefully that makes sense, but we'll do some examples. And domain is the possible values of x. If x is in the numerator, then the domain would be all real numbers. So let's start with the examples. We're going to perform the indicated operation and state the domain. So we're given the equations for f of x and g of x, and for number 1, we want to find g of x plus f of x. So we're just going to replace g of x, which is this. So we're going to replace it with the long equation. So 5x to the 1/3 plus 4x to the 1/2. And then we have a plus, so this part was g of x. And f of x is this part here. So we have negative 3x to the 1/3 plus 4x to the 1/2. Then we're going to see if we can combine anything. So we have an x to the 1/3 here and here. So we can combine those, and that would become 2x to the 1/3. And we also have x to the 1/2 here and here. So that'll be plus 8x to the 1/2. And we can't combine these because the exponent for the x is different, so this would be the final answer. Number 2, we have g of x minus f of x. So this would be 5x to the 1/3 plus 4x to the 1/2 minus f of x, which is negative 3x to the 1/3 plus 4x to the 1/2. So first we'll want to distribute this negative sign. So we get 5x to the 1/3 plus 4x to the 1/2 plus 3x to the 1/3 minus 4x to the 1/2. And then again, we're going to see if we can combine any like terms. So we have 5x to the 1/3 and 3x to the 1/3. Those both have x to the 1/3, so we can add those together. We'll get 8x to the 1/3. And we have 4x to the 1/2 and minus 4x to the 1/2. So that'll become 0. So 8x to the 1/3 would be our final answer. Okay, next we have another equation. F of x is 4x to the 2/3 and g of x is 5x to the 1/2. Oh, shoot, sorry. I forgot to find the domains. Okay, so domain again is possible values of x. So for this problem, There's no x in the denominator, so it's all real numbers. And then same with this one. Domain is all real numbers because x is in the numerator, or it's not in the denominator. Okay, number 3, we want to find f of x times g of x. So that's 4x to the 2/3 times 5x to the 1/2. So first I'm going to multiply the whole numbers together. 4 times 5, that's going to be 20. And then we have x to the 2/3 times x to the 1/2. So that means we're going to add the fractions together. So 2/3 plus 1/2, the common denominator would be 6. So we would multiply this one by 2 and this one by 3. So this would be 4, this would be 3, and then we'll get 7 over 6. So we get 20x to the 7 over 6 power. And for this problem, since there's no negative in the exponent, that means x is in the numerator as well. So the domain is all real numbers. Okay, number 4, we have f of x over g of x. So f of x is 4x to the 2/3, and g of x is 5x to the 1/2. So first I'm going to look at the numbers. We have 5 over 4. We can't simplify that, so I'm just going to leave the numbers where they are. Oops, sorry. 4 is in the numerator and 5 is in the denominator. And for the x's, we can subtract the exponents because they have the same base. So we have 2 over 3 minus 1/2. So again, we need a common denominator, which is 6. Multiply this one by 2, this one by 3. So we'll get 4 and 3, and then that'll simplify to 1/2. So that means we have x to the 1/6 power in the numerator. And since x is in the numerator, that means the domain is going to be all real numbers. Okay, next we want to find the indicated value. We're given f of x, g of x, and h of x, and we want to find f of g of -3. So for these, we always want to start with the inside first. So I'm going to start by finding what g of -3 is. So g of -3 would be when we plug in -3 for x in the g equation. So that'll be -3 squared. -3 squared is 9, so g of -3 is 9. So now I'm going to replace all of this with -9. So really what we're looking for now is f of -9. So I'm going to plug in -9 into the f equation. So that'll be 3 times -9 plus 2. So we get f of -9 equals -27 plus 2. So f of -9 equals -25. So that means f of g of -3 equals -25. Okay, next we want to find h of f of -9. So again, we want to find this part first. So f of -9 would be when we plug in -9 in for the f equation. So that's going to be -27 plus 2. So f of -9 equals -25, and that's what we're going to plug in here. So what we want to find really is h of -25. So now I'm going to look for the h equation, which is this fraction here, and I'm going to plug in -25 in for x. So that'll be -25 minus 2 over 5. Oops. So h of -25 will equal -27 over 5. And we can't simplify that, so that means h of f of negative 9 equals negative 27 over 5. Okay, number 7 and 8, we want to perform the indicated operation and state the domain. So we're given f of x, g of x, and h of x. For number 7, we want to find f of g of x. So that means we're replacing all of the x's in f with 2x minus 7, because that's what this equals. So if it helps, you can think of it this way. F of 2x minus 7. So we're replacing all of the x values in f with 2x minus 7. So that'll be 3 times 2x minus 7 to the negative 1 power. And since it has a negative exponent, that means we want to bring it down to the denominator. So that'll be 3 over 2x minus 7. So I'm going to call this f of g of x again, since we can't simplify. And for this one, this actually has a domain that's not all real numbers because we have x in the denominator. So for the domain, we would set it equal to 0, or not equal to 0, because you can't divide by 0 and you can't have 0 in the denominator, like as what the problem equals. So we would solve this. We'll get 2x can't equal 7, and then divide by 2. Oops, sorry. So x can't equal 7 over 2, and that would be the domain. So to set up the domain, all you do is set the denominator not equal to 0. And the solving part would be the same as if it was equal to. Hopefully that makes sense. Okay, and then for the last one, we want to find h of g of x. So in the h equation, I want to replace all of the x's with 2x minus 7. So that'll be 2x minus 7 plus 4 over 3. And then I'm going to simplify. So I would get 2x minus 3 over 3. And I'm going to rewrite this as h of g of x. So this here is just if it helps you instead of writing this, but they mean the same thing. Okay, and then for this problem, x is in the numerator, so the domain would be all real numbers.